Okay, here we go. All right. So let's say we have this equation. Okay? F of x equals x cubed plus 4x squared minus 16x minus 64. Okay? First off, how many zeros are there? I have 3 zeros for sure. Correct? Does everybody agree with me? Of those 3 zeros, how many of those zeros could be real? What's the least amount? 1. Because if you guys think about this, in x cubed, on our graph, we have to cross at least once, don't we? Could we cross more? How many, what else could we do? We could cross twice? Okay, but one of those would have to be a bounce, correct? Is everybody there with me? Could I cross 3 times? Okay. That would give me 1, 2, 3 zeros. Those would all be real zeros. Now, are they always a rational zero? What's first off a rational number? Go ahead. Okay. Yep, it doesn't necessarily have to repeat, but it's a number that can be written as a fraction. Anything that has a repeating decimal can be written as a fraction. You guys all know why? Anybody know? Has anybody ever showed you? Let's just show you really quick. What do we know about a third? It's 0.3333 repeating, correct? You guys agree with me on that? Okay. We're going to call him x. How many times do I need to move my decimal until I get past the repeating part? I just have to move it once, don't I? Does everybody see that? So I'm going to times this whole thing by 10. So I'm going to times this side by 10, so I get 10x. And this side I'll get 3.33333, correct? You guys with me on that? Let's go ahead and subtract these guys. What's 10x minus x? 9x. So what did I do? I went this minus this. So what if I go this minus this? What do I get? 3. And therefore x is 3/9, which is, that's how it comes about. That's why, once again, if it has a repeating pattern, I can get rid of it. Let me just show you another one. What if I had 42.23737 and so forth? Okay, does that make sense? How many times do I have to move my decimal until I get through my repeating part? I have to multiply it by 100, don't I? Okay, so I multiply it by 100, so I get 100x equals 423. Oh, excuse me. Oh, that's 1,000, isn't it? Sorry about that. 0.3737. So now, if I subtracted these two, would it get rid of each other? Yes or no? It wouldn't. So now that I've repeated past this, I could actually just times it by right there by 10, and I get 10x equals 42.3737 and so forth. Could I subtract these two and get rid of the repeater? So I'm going to go this minus this. So 4237 minus 42 is, what is that? 4,195 equals, I want that minus that is 990x. See how that works though? I can always get it into a decimal. I mean a fraction. That's the reason why it works. Okay, but it's anything that can be written as a fraction. Okay, so coming back, did I go up or down? So coming back to this equation, I'm going to write it over here just so we get a fresh start. I am looking for my rational zeros. Are there other zeros besides rational zeros that are zeros? Could I have the square root of 4? I mean, oh, sorry, not square root of 4. Square root of 3. That's a real zero, is it not? But is it a rational zero? So what I'm going to show you right now is the possible rational zero. Okay? Now, we've talked about linear pairs before, right? After we found all of our zeros, have we wrote it as a linear pair before? Remember, what would it be if x is 2, 1, negative 3? This would be as a linear pair, correct? Does everybody agree with me on that? But let me ask you guys this question. As a linear pairs, when I multiply these linear pairs together, what does x times x times x have to equal? It needs to equal x cubed here, right? What if this was a 2x cubed? What does this need to equal? 2x cubed. So one of these better gosh darn have a 2 in there, right? Does that make sense? Everybody with me on that? One of the front numbers. What do these back numbers have to multiply to be? Negative 64. Okay, does that make sense? So if you think about it, what's possible answers? Well, shouldn't these three numbers times to be negative 64? And these three numbers times to be, in our case, 1. So what are possibilities for these ending spots? Only 8, 4, and 2? 8, 4, and 2 is a possibility. I like that. That is a possibility. But are those the only ones? By the way, this wouldn't even work anyway. Can somebody tell me why? Because that's positive 64. So one of those would need to be at least negative, but which one is? You get what I'm trying to get at here? Okay. So what are some possibilities? Well, here's my whole possibility right here. I'm going to do a chart really quick. Well, I know 1 and 64, 2 and 32, 3 can 3 go? No, 4, 16, 5 can't go, 6 can't go, 8 and 8. So our possibilities are right here, 1, 2, 4, 8, 16, 32, 64. Now those are half of our possibilities. Can anybody tell me why it's half of our possibilities? Go ahead. Because this could be negative, so these are all plus or minus. Right? But notice all of those have to be, when I go ahead and pick one, so let's say if 64 comes out, who do I know at least the other two are going to be? 1 and negative 1. Because I have to multiply to become a negative 64, don't I? You guys get what I'm going at here? So what technically all I have to do is I go through synthetic division. Now this is a lot, right? Quite a few numbers there, isn't it? To choose. And I'm going to show you how you can pinpoint some other ways. Okay? Now, really quickly, just so we don't spend our time, is this something that we could have factored though? Factor by grouping. So let's just try and find it, and I'm going to show you some things, okay? So first off, these guys share what? X squared. I'm left with x plus 4. These guys share negative 16. I'm left with x plus 4. So I pull that out. X plus 4, x squared minus 16. Now I can keep factoring him, but just bear with me for a moment, okay? All right, here's what we're going to do. What's the coefficient that I use then? 1, 4, negative 16, negative 64. Okay, is every time am I going to be able to factor it like factor by grouping? No, I'm not. Huh? So sometimes you're going to have to go through that big list that we just wrote of 1, 2, 4, 8, 16, 32, and 64 and have to guess and check through that. Okay, Is it always the perfect solution? No, but does it help us if we didn't know what to do to be able to find some of these? Yes. Okay, so remember, as I factored that, what was one of my zeros? And it was x plus 4 and then x squared minus 16. What was one of my zeros here? Negative 4, right? Okay, let's try synthetic and just check. Okay, so as we go through, notice something that I noticed a few times, people forgot to pull their 1 straight down. Like if this was a 3, some people just put a 1. But what is this always going to be? Whatever that coefficient is, right? So this is a 1. What do we do here? We multiply, okay? Negative 4 times 1 is what? Negative 4. What do we get there? 0. Negative 4 times 0 is 0. Negative 16. Then I get 64, which is 0. So once again, what does this mean? This is a 0 because this is the coordinate negative 4, 0, right? Because remember our remainder is 0, so that tells us that this was a perfect factor because there's no remainder, which we showed because of the factoring aspect. You guys agree with me? Okay, now, once again, if this was 1x cubed, what does this represent down here? This is 1x squared, or just x squared minus 16. And x squared minus 16, what can I always do there? I can either A, factor, or quadratic formula him, right? Does that make sense? But in this case, I know what x squared minus 16 is, don't I? You should at least. Okay. What is x squared minus 16? So I want to factor it though. So that's x minus 4, x plus 4. Okay. What was my other factor that I did find? X plus 4. Really quickly. What's x times x times x? X cubed. Negative 4 times 4. Negative 16 times 4. Negative 64. Did I get my first coefficient and my last coefficient? Yeah, I did. See how that works? Okay. Now, what if it's x to the 5th? How many zeros am I going to have to try to find first? I'm going to have to find a total of 5, right? But I want to get down and find 3, because if I find 3, what does that get me down to be? An x squared. And after x squared, I can always factor, right? Okay, let's try another one. We'll talk a little bit about it. Thank you for leaving my stuff down here. Appreciate you anytime. Okay. We'll try him. I haven't tried this one. All right. Ladies and gentlemen, I want to find the zeros of this function. The zeros of this function. So really quickly, let's just think of possibilities to go ahead and get this representation in terms of factoring. What are some possibilities? That's a big hippo butt. Okay? But what does one of these coefficients have to be in the front? A 2. Because one of these has to be a 2x, doesn't it? Okay, and then these guys, if that's the case, these guys have to be x, don't they? Would you guys agree with that? Okay, what about all these on the end? What are they going to be? 1. Now, I could have a negative 1, a negative 1, and a positive 1, couldn't I? Or I could have a plus 1 here, a negative there, and a negative there. Or I could have a plus 1, plus 1, plus 1 as well. Everybody see that idea? Okay. So, let me show you actually how we find our possible rational zeros. Write that down. Possible rational zeros. Now, once again, does this find all of our real zeros? This is just giving us possibilities for rational zeros. Would you guys agree with me? Okay, here's what you do, okay, is you go ahead and say, what are the factors of the constant? What are the factors of my constant? 1. Okay, factors of my constant, and notice it's not only 1, it's plus or minus 1. Do you guys agree with that? Because I could get -1 times -1 times a positive 1, and that would give me there, wouldn't it? As we discussed up here, different options. Okay, and then, so this is once again of the constant. Okay, what are my factors of my leading coefficient? 1 and 2. Once again, could be plus or minus, because this could be -2, a -1, and a positive 1. That would still come out, wouldn't it? You guys agree with me on that? Because all it has to do is multiply to be a 2x cubed, correct? So it could have different sign choices. So once again, plus or minus. So ladies and gentlemen, once again, this is from our what? Where do these come from? They come from our leading coefficient. Now why? Why am I going to get these from, notice, these numbers divided by these numbers? So what are our possibilities? What's 1 divided by 1? 1. So we have plus or minus 1. What's the other option we have? 1 divided by 2. Those are our 4 options for possible rational zeros. Yes, I just put plus or minus out front, but sometimes people do plus or minus in front of every single one. I just think that's overkill. Please understand in my notation, this is represented for everyone that's coming past. Is that okay with everybody? Because I don't want to do plus or minus a bajillion times. Okay, why is it okay that it's either 1 or a half, plus or minus in this case? Well, think about it. What's the value that could be here if this was x plus 1? -1, right? Oh, that's a possibility, wasn't it? What's the possibility here if this was x minus 1? 1. How about here? 2x plus 1. -1/2, if it was 2x minus 1. +1/2. Now those all come through because different possibilities do. Does that make sense? And why do I only use these and not these other coefficients inside? Because when I factor it, all the front coefficients have to multiply to become the leading coefficient, correct? All the last, or the constants of each linear factor, have to multiply to become the constant, right? And that's where this is coming from. So let's go ahead and do this choice again. I'm going to go on to the next page. Actually, just scroll down. Somebody tell me, once again, what was my coefficients that I wrote up there? It was 2, 5, 4, and 1. Okay, I'm going to teach you guys a trick really quick. Okay? Ladies and gentlemen, I'm going to do synthetic division. But I already know a number I'm not going to choose. Actually, 2 of them. Anybody know a number I will not choose? I won't choose 1 or I won't choose a half. Let me explain. You see how all of these are the same sign? How will I ever get zeros if I'm always adding these? Would I ever? Good thing to write in your notes. If this is all positives, you will never have a positive 0. If your coefficients are all positive, you will not have a positive 0. It won't come out. Because there's no way for those to ever switch your signs to subtract to become a 0. Does that make sense what I'm saying by that? Let me just show you. I'm going to put 1 in. 1, 2, what do we do here? Multiply, add, multiply, add, multiply, add. You notice how I would never get to be 0 because I'm consistently just adding. Now what if there was a minus in here? Because then that could overpower it to make it then a positive times a negative again, and then I can start playing around, and that's okay. As long as there's one negative in there, you could have a positive 0. But if they're all just pure positives, we have a solution. We have a slight dilemma. Does that make sense to everybody? This room is so darn hot, guys. You gotta jump around, get your wiggles out, because I'm telling you, Jared's about sleeping on me. Right? Okay, so once again, what were my four choices on my possible rational zeros? I had plus or minus, they're right here, right? I've already picked one of my choices. Did it work? Is a half going to work again? No, because once again, these are all. So I'm going to try again. Is this going to be sometimes guess and check today? It is. Okay, but I'm going to teach you some tricks as well as we go along. So I'm going to try it again. It was 2, 5, 4, 1. Is that correct? Let's go ahead, ladies and gentlemen. Let's try -1 as a 0. Okay? Let's try that one. Because we only have two options, -1 and -1/2 to get the other one. Okay? So let's try. What's -1 times 2? -2. We get a 3. -3. 1. -1. What do we know then? He is a factor. He is a factor, isn't he? So one of our factors already right here is x plus 1. Does everybody understand that? Because -1 was a 0. So he is a factor of that polynomial. Huh? How many 0 possibilities did we say there has to be? How many zeros are we going to find? Nope. On this one, it was 3 because it was an x cubed. If it was x to the 5th, it would be 5, right? And I'd expect you to find all 5. Okay? But what is this now? Once again, what was the 2, 5, 4, 1 representing? This was 2x cubed, wasn't it? What is this representing? So what do we do at a 2x squared situation? We can factor, can't we? Or, in this case, we can factor. Okay? But if we couldn't, what would we do? Well, quadratic formula. Could we get imaginary solutions? Yeah, that would still give us 2 zeros. Plus him, that's our 3 zeros, but they're just not all real zeros. Right? Does everybody get me on that? All right, here we go. Notice 2 times 1 gives me 2. Factors of 2 that give me the 3. 2 and 1. So I'm going to say, okay, I can just hurry and do this. Hopefully you guys, once again, factoring is important. Like I told you, it's never going to go away. So I'm just quickly factoring, though, because I would rather spend time on showing you the real stuff instead of the things that you should know by now. Right? So I need a plus 1 here and an x plus 1 here. Notice that would give me 2x plus x to give me 3x. Okay? What's my other zeros? What's the value that makes him 0? -1/2 makes that guy 0, right? What's the value that makes him 0? -1. And we already had this guy up here who was -1 as well. If I wanted you to write these as a product of linear factors, what would I do? I'd say 2x plus 1, x plus 1, and x plus 1 again, or you could say x plus 1 squared. Does that make sense to everybody? But notice these are all the factors of the 0. Okay? Now, are we understanding what we're kind of doing today? The goal is to go ahead and find all the zeros. But there's some other things just as well. Okay? Can I do synthetic? Can somebody first off tell me this? Oh my goodness. Stop it. Stop it! Oh, you got it. All right. Now, we should already know the zeros of this, don't we? What are the zeros of x squared plus 1? I and -I. Right? Because if I solve this for 0, Is everybody with me on that? Any questions today? Braden, are you tired too? I like your shirt. Where do you get a shirt like that? Does it come in 3XLT? Can you look into that for me? Okay. What if I told you that one of my zeros was an imaginary number? Can I still do synthetic? Let's try. So notice we had x squared plus 1, right? How do we write that to do synthetic? What's the coefficients that are needed? 1, missing the linear term, so I need to put a placeholder, right? And 1. One of our zeros was I, correct? We already know that. I'm just showing you that it can come about. So 1 times I is I. What's 0 plus I? I. What's I times I? Which is negative 1. Does it show it's a 0? So if I told you that one of my factors was I, or 2 minus I, could I go ahead and do synthetic still? I could, couldn't I? But if I told you I is a 0, who else do I know is a 0? Negative I, and that's already here, because once again, this was x squared, correct? Does everybody agree with me there? If he's x squared, what's this term? X. So this is the same thing as x plus I. This guy gave me what? X minus I. Notice what's the value that makes him 0? Negative I, and what's the value that makes him 0? I. Okay, is this in linear factors? It is, huh? What if I told you guys that 2 minus I was a 0? Who's another 0 that comes? Because imaginaries always come in conjugate pairs. Why do they come in conjugate pairs? Because I had to take a square root. And when I take a square root, I always need to do the plus or minus. That's why they will always come. How about if I gave you square root of 3 as a 0? Who else is 1? Negative square root of 3. Because, once again, anything that deals with a square root will come with a conjugate pair because of the plus or minus situation. I'm gonna wake you up, Jake. Wake up, Jacob. Johnny shot a bear. Come on. Wake up, Jacob. Johnny shot a bear. Right through the nose hole. Didn't disturb the hair. That's what she's doing. It's crazy, I know. Okay. You guys are all good. Okay. Let's try one more. And then we'll get into some things. All right. What are my possible rational roots? Possible rational roots. Doesn't mean they are going to be roots, but what are my possible rational roots? Where do I find that from? If you'll remember on our last one, we went ahead and remember we did it the constant, the factors of the constant divided by the factors of the leading coefficient. That's how you find the possible rational root. So what are my factors of my constant? 1, 3, 9, and 27. Does everybody agree with that? If you need to, I could do a chart, right, just to check them out. 4 can't go, 5 can't go, 6 can't go, 7 can't go, 8 can't go, 9's on the other side, shows that I'm done, correct? Okay. So therefore, I divide it by the factors of who? Leading coefficient, which is plus or minus 1. So really, all this just comes out to be what, though? Plus or minus 1, 3, 9, 27. Yes, sir. Once again, because it could be, how can I get to an x cubed? I could have x by by x. All of those were coefficients of 1, right? Or I could have negative x times negative x times x. Negative x times negative x becomes x squared times x again. So those are the reasons why it could be plus. Does that answer your question? Okay. How can I get to a positive 27? I could have a negative 3, a positive 3, and another 3. Positive 1, negative 1, positive 1, negative 1, and another negative 1, right? I can have just different scores. Does that answer your question? Okay, so here we go. Once again, I'm missing something, am I not? What am I missing? My quadratic term, correct? So what do I need to do when I do synthetic? Placeholder, so I have 1, 0, what was next, please? Negative 18, and then a positive 27, agreed? All right, now so far we haven't really messed up yet, have we? We haven't found one except for that one that I chose one just to show you guys. But when I'm guessing, once again I have these choices, plus or minus 1, 3, 9, and 27, could I have a positive 0? Could I have a positive 0? Yeah, because I don't have just pure constants here, meaning pure positive constants, right? I have a switch there. So could one of them be 1? Could it be 3, 9, or 27? Okay, let's go ahead and pick a point, just in general. How about we pick 1? Okay, because I'm going to show you it doesn't work. Because I know it doesn't work, and I'll show you why in a minute. I'm going to pick 1. 1. 1 times 1 is 1. 0 plus 1 is 1. 1 times 1 is 1. Negative 18. Negative 17. 1 times negative 17 is, and I have 10. Guys, remember using the remainder theorem. Isn't this a coordinate point? Because whatever was left over was the y value of this x value. Remember how we talked about that? So is this bad information? No, it's not. Even though I failed, meaning to pick the right number, it's not bad information. So let me show you. I'm going to do it all over again, but I'm going to pick 9 this time. Once again, it was 1, 0, negative 18, 27. Okay, let's pick 9 this time. And I might be right, I might be wrong. I'm not sure. Okay, so 9. Bring down the 1. 9 times 1 is 9. 63, right? Big A freaking number. What is that? 567. So that's 594. Notice, ladies and gentlemen, so that point's 9, 594. So on a graph, okay, on a graph, I'm at 110, and then at 9, I'm all the way up at 594. Do you think I'm going to have a 0 in between there? Because it's just continuing to grow. Could there be? What's the only other 0 that could be in there? Positive 3. Let's hurry, I'm just going to check it really quick. That would be 1, that's a 3, 3. 3 times 3 is 9. Oh, 3 actually does work. Let's try it, though. Dang it. That's bad that I gave you that information. 1, 0, negative 18, and 27. Okay, let's pick it. Now, I was wrong. I thought maybe it would be in between, but I tried. But it's okay. Because maybe what happened is that the graph went like this. It went to 1, down, and then rose really quickly. Right? Now this other part comes over here probably or something like that. Does that make sense? Okay. But once again, this was x cubed, so what's this? X squared, right? Is everybody there with me? So, this is x squared plus 3x minus 9. Is that a factorable quadratic? What's the factors of 9 that give me to be 3? 1 and 9 don't give me to be 3. 3 and 3 don't give me to be 3. So how do I find my other zeros? Quadratic. So here we go. We're going to find quadratic. X equals, really bouncing, negative 3 plus or minus square root of 3 squared minus 4 times 1 times negative 9 all over 2a 2. So that's negative 3. This is 9 minus a minus 36. So that's square root of 45. What's in 45? 9 and 5. 3 and 3. So we have buddies, right? Remember to put the buddies on the outside and whoever's left over on the inside. Okay? Ladies and gentlemen, do I have my 3 zeros? How many zeros are coming from here? 2. How many are coming from here? 1. Okay? What was that? Nobody loves it. I'm not saying he's weird. Just. What if I asked you guys to write these as linear factors? Can I show you how to do that? Okay, so what was one of our very first zeros, the one that actually factored? It was positive 3, correct? So how do I write that as a factor? X minus 3. Does everybody agree with that? Yes, no? Okay. Now, ladies and gentlemen, let's get this stuff to the other side. So I'm going to subtract this, and let's do the plus. I'd subtract, so it'd be x plus 3 minus 3 root 5 all over 2. There's one of them. What's the other one? X. How do I get rid of him to the other side? Add. So it'd be x plus 3 plus 3 root 5 all over 2. Okay. Just like I would do with the other factors, right? Should we bow down to the queen? Ha ha! That was all I got? That was semi-funny to me. I thought it was really good, personally, but whatever. Very cool. Okay. You choose. Oh. Okay, pick a number in your head on which one's 1 or 2. I'll choose 2. There it is, see? That's how we do that one. I swear I have a hole in the game. Drift right out. Okay, I would like to talk to you guys about Descartes' rule of signs. Okay? D-E-S-C-A-R-T-E-S. Descartes. Rule of signs. And it kind of goes into the fact of the matter. Remember how we had all positive coefficients, and notice I had no negative? I got filled this morning. I'm so good. You can go out to my truck. Oh, damn, my truck's out in the. You want to go all the way out there? It's not long. In the back seat is my big fella. 64 ouncer, yes. Because I'm going to be here many hours today. I got range today. Okay, what was our last example that I had? I had x cubed minus 18x plus 27. Okay? I want us to see the sign changes between each coefficient. You guys tell me how many times we switch. He's a positive. He's a negative. That's a sign change, isn't it? Does everybody see that? It's, I guarantee. I will now start locking my truck, you little scumbags, no thieves. Okay? How about from here to here? That's a sign change. So how many sign changes did we have? 2. So ladies and gentlemen, we will have 2 or 0 positives. We will have 2 or 0 positive roots. Can I ask how many positive roots did we have? We had 2, didn't we? Let me explain why. Okay, one of them was 3. There's one of them. But then notice -3 plus this stuff is larger than 3. Because what's the square root of 45? I don't really know, but square root of 3 would be 9. So I know square root of 45 is greater than square root of 9. So I know -3 plus square root of 45 over 2 is going to be positive. So I have 2 positive zeros. Now, why could it be 0? Why do I go down by increments of 2? Because once again, do imaginaries come in just singles? What do imaginaries always come in? Conjugate pairs. So they always come in pairs, hence why I got to drop down by 2. So, really quickly, discards for those signs. Look at the sign changes. Notice, however many sign changes there are, then go down by increments of 2. Those are your possibilities. How could that be helpful? Well, if I find 1 positive 0, what do I automatically know? There's 1 more, right? Now, does it have to be a rational positive 0? Did ours come out to be a rational positive 0 as that other one? Not necessarily, right? Okay, now this is for positive. How do I find out the negative 0? Well, you take the function. It's kind of like an odd function. You just replace everything with -x. So if I replace this guy with -x, what does he come out to be? -x cubed, right? What does he come out to be? A positive 18x plus 27. How many sign changes? 1. So I had 1 -0 for sure. Should we do the other one? What was one of our other ones we chose? How about the one that we did with the pure coefficient straight across? Can somebody read me the formula? The one that had, it was like 2x cubed. Yep. So we have 2x cubed. Okay, so here's another function. How many sign changes did we have? 0. So hence, we had 0 positive choices. Because there was no sign change. Does that make sense how I was talking about how you won't have any positives? Because there is no sign changes there, so therefore it can't go back and forth. Okay, now what if I replace this with -x? Let's see our new equation. What would it come out to be? The -2x cubed. Would he change? No. Would he change? Okay. How many sign changes do we have here? 1, 2, 3. So what are our choices here? 3 or 1 negatives. Can somebody tell me what were my zeros for that problem that we already found out? -1, -1 again, and who was the other one? -0.5. All of those were 3. Discard rule of thumb. Okay, yeah. Every time. So anytime you go down by 2s, because once again, if I have 3 zeros, right, I could have 1 real and 2 imaginary. Does that make sense? And so notice, what if I did? Notice I had all 3 of them being negative, no were positive. What do those add up to be? 3. What if it came out that I had 1 negative? I know I will have 0 positive, so that means I should have 2 of them. Does that answer your question? That's why it goes down by 2. Okay. What if it came out to be, I have, let's say it's an x to the 5th graph. Just bear with me here. Okay, and it came out I have 4, 2, or 0 positives. Okay, and I have 1 negative. What are my choices? I could have 1 negative for sure because it's guaranteed, right? 1 negative, 4 positive. Does that have to be x to the 5th? I could have 1 negative, 2 positive. I'm at 3, so that means what? I could have 2 imaginary solutions. I could have 1 negative and 0 positive, which means I have how many imaginary solutions? That's why you go down by increment. Is everybody there with me? Because every time I don't, if I said 1 positive and 3 here, that means I'd have 1 imaginary. Is that possible? No. Okay. Any questions so far? All right. I would like us to write a polynomial with these 3 zeros. It's an x cubed, okay? And I give you x is -5 and 1 minus I. I would like to write a possible x cubed with those zeros. What's my issue, though? Right now, I only have 2 zeros, don't I? But who's my third? 1 plus I. Because remember, anything with imaginaries always come with their conjugate pair. Oops. Does everybody understand why they always come with that? Now, how would I write an equation? This was very similar to what we had on our test, correct? Where I gave you 4, -5, and 5, I believe, as zeros, correct? Okay. So how would I write him as a binomial? X plus 5. Basically, I set him equal and I added him over, right? Same thing here. What would he be? X minus 1 plus I. Yes? No? Maybe so? Do we feel okay? What about this guy? X minus 1 minus I. Is that my cubic polynomial yet? Are we into a polynomial? We're just into factored form, aren't we? So how do I get him into a polynomial? I'm going to distribute. Who would you guys want to distribute first? Always, if you ever have conjugate pairs, multiply those suckers together first. So I don't know if any of you guys on your test did -5 and 5 first. When you multiplied those two together, you got x squared minus 25. Then it was easier to multiply him through. Right? Here we go. What's x times x? X squared. X times -1 is -x. Negative ix. Negative x again. Positive 1. Positive I. I times x is positive ix. Negative I. Minus I squared, which is plus 1. You with me? All I did, I saw just a dirty look, so I want to make sure. So notice these guys will always cancel out, and so will these guys. If they don't, you did something wrong. Because that's the nice thing about conjugate pairs. Okay? So, x squared minus 2x plus 2. X plus 5. Am I done? What do I got to do now? Distribute him through, right? So he's just a little, it takes a little bit of time, doesn't it? But it's something that's not too shabby. So I distribute through x cubed minus 2x squared plus 2x plus 5x squared minus 10x plus 10. Which was x cubed plus 3x squared minus 8x plus 10. How could I check to make sure that I did that right? Anybody know? I could go ahead and factor, but this isn't a nice factor one, is it? But what, do I already know my zeros? -5 was a 0, huh? So what could I do? I could do synthetic and check to see if it is a 0. Because if it's not, then did you do something wrong? You know what I mean? Am I most likely going to do that? Probably not, but could you? Sure. Okay. All right, let's keep going. One more. All right, this one's not the most pleasant, but we'll go for it. I want to find out where it's equal to 0. Okay, so right now, how many zeros are we going to have? 3, right? Okay, I need to find 3. Let's check to see how many positives I should have. How do I find out to see how many positives I should have? The Stark's rule of signs. Yes, sir. A 4, sir. Thank you. So let's check out how many positive zeros I should have. Notice the only sign change I have is 1. So I only have one positive number. Okay? And sometimes this is what I do, ladies and gentlemen, to show you what I do for the negative. Is he going to change or stay the same when I find the negative? He's going to change because I'm plugging negative x in, right? So he's going to change, so he'll be a negative number. Is he going to stay the same or change? Stay the same. So he's going to be positive. Is he going to change or stay the same? Change, so he's a positive, and -4 has to stay the same, so he's a negative. How many sign changes? 1, 2. So that means I should have 2 or 0 negative. Okay? But I guarantee I have one positive, right? Does that one positive have to be one of my rational possibilities? I want to make sure that you guys understand that's a no. Okay? All right, here we go. So let's look at our possible rationals. What are our possible rational numbers that I can pick? Well, what's the factors of 4? 1, 2, 4, plus or minus, right? Over, what's the factors of 36? This one sucks. 1, 2, 3, 4, 6, 9, 12, 18, 36. Holy shizzy mofo. So what's all of our possible rationals, guys? You ready? Okay, here we go. Take a deep breath. Because this is part of your homework, is just listing the possible rationals, and that's all you have to do for the question. List the possible. Okay, here we go. What's 1 divided by 1? 1. 2 divided by 1? 2. 4 divided by 1? 4. Okay, here we go now. What's 1 divided by 2? A half. 2 divided by 2, which we already have written, so I don't need to rewrite again. Does that make sense? Okay, 4 divided by 2. Already written, so I don't have to do it again. Agreed? Okay. 1 divided by 3. A third. 2/3. 4/3. Okay, now I gotta go to 4. 1 divided by 4. A fourth. 2 divided by 4. Half is already there. 4 divided by 4. Already there, correct? Okay, now I'm on a 6. 1 divided by 6. 1/6. 1/3. 2 6 is 1/3, which is already there. Yeah. A lot, because I'm going to be out on the range. So yeah. Okay. What did I get? 1 divided by 6, 2 divided by 6, 4 divided by 6 is already up there too, right? 1 divided by 9, 2 divided by 9, 4 divided by 9. Holy shiznit. Keep going. Okay. 1 divided by 12. 1/12. 2 divided by 12. 1/6 is already up there. 4 divided by 12. 1/3 is already up there. 1 divided by 18. 1/18. 2 divided by 18. 1/9. 4 divided by 18. 2/9 is already up there, right? 1 divided by 36. 1/36. 2 divided by 36. 1/18. 3 divided by 1. 4 divided by 1. Oh my hell. 4 divided by 36. So, plus or minus. So how many choices are there to choose from? Too many to freaking try, I'll be honest. Okay. But, is there 30 choices? Okay. Okay. I'm going to show you guys a trick really quick, but that's not going to work on this one. Always, always, always add your coefficients together. What's 36 plus 144? 180 minus 1. 179 minus 4. 175. Guess what? Guess what I just checked? I checked the value of 1. Let me just show you here on another problem. Notice really quick, x squared minus 3x plus 2. Okay? Here's my coefficients. What did that add up to be? 1, -3, and 2. They add up to be 0. So try 1. It'll always be that case. If you can add your coefficients together and equal 0, 1 is a factor. So just something to check for yourself, something to note for yourself, is if your coefficients add to be 0, it'll always 1 will be. Okay? What's happening here is it's just doing division. By that, and it'll just come right out. Okay? Anyway, let's come back to our problem. By the way, that can factor by grouping. I just noticed that. What do these guys have in common? 36x squared. And I'm left with an x plus 4. What do these guys have in common? -1, I'm left with x plus 4. So what do we already know one of our zeros is? -4. Let's just try it. Let's go through it. Somebody read me my coefficients again. It was 36, 144, -1, -4. Am I correct? Okay. So we know -4 should work, correct? Here we go. Let's try. 36. -4 times 36 is -144, which is 0, which is 0, which is -1, which is 4, which is 0. What's left over? 36x squared minus 1, which by our factoring, we already saw that. Oh, didn't we? What is this called? Difference of squares. So this is 6x minus 1 and 6x plus 1. And what was our other factor? X plus 4. So that's all of it in factored form. What are our zeros? -4, 1/6. Did that work with what I said above with our zeros? I have 2 negative, 1 positive. 1 positive, 2 negative. Kind of cool that it works out that way, doesn't it? Sensory overload. What's our main goal that we've talked about today, though? Finding the possible rational zeros is our goal today. And how do we do so? Take the factors of our constant, divide it by the factors of our leading coefficient. And those give us all of our possibilities. Okay? I believe you might have a graph to do, just to sketch. So if I was going to sketch this graph, just once again, okay, if I was going to sketch this graph, how would I do so? Here we go. Just remembering from the test. Here's our zeros. Here's 1, so negative a 6 is really close, right? Positive a 6 is really close, and negative 4 is down here. What was our leading coefficient? Positive 36. What was our degree? X cubed. So we're like this, correct? Coming from down. Notice, did any of these guys have multiplicities? So that means they're all multiplicities of 1. So that means they're all going to cross. That's kind of a sketch of what happens. Okay. Any questions there? I believe that's everything within it, okay? Once again, I just want to clarify, if I said that this guy was a 0, let's say x was 0, 1, square root of 2. Who else is a 0? Negative square root of 2, because once again, the conjugate pair always comes. What if it was 1 plus square root of 2? 1 minus square root of 2 would come along as well. Okay, same with anything with a radical. Okay, still good? On your test, I just looked at it today. You're going to need to know how to put things in linear factors. So after you find the zeros, you can put them in linear factors. Can you find every single zero? Can you tell me all the possible rational zeros? Can you tell me how many possible positive zeros there could be? Could you tell me how many negative zeros there could be? Okay, half your test almost comes off this concept. No, we got quite a way. But we are going to have a review day as we get time. Remember, when this would be in linear factors is right here for me. That right there is linear factors. Even when I have my imaginaries, remember how I still put them in terms of linear factors as well. How I found my negative zeros? Okay, so let's use this last example that I kind of had. This guy right here, okay? So let's find our positive zeros first. So notice that is 1 sign change, 2 sign changes. So notice I have 2 or 0 positives. Okay, now to find my negative, does that make sense right there? Okay, because once again, we go down by increments of 2 because of the fact of how do imaginary pairs come. They always come in pairs. You're a rock star. You're a freaking rock star. Did you run out there or did you walk out there? I was curious. You saw us in my truck? Good, because I was nervous. That is sketchy. Yeah. Don't park in the freaking range parking lot. Okay. Now, how do I find the negative? I replace x with negative x. So that's negative x squared minus 3 times negative x plus 2. And basically, be honest with yourself, what are they going to change if they are odd powers, right? So is he going to change? He just comes out to be x squared, doesn't he? Is this guy going to change? He's positive 3x. How about him? 2. How many sign changes? I will have 0 Nope, right here. How many sign changes? This is positive, 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 so I have 0 changes. So therefore, I'll have 0 negatives. So either A, I'll have 2 positives, or I'll have 2 imaginary. Does that make sense? And notice it came out 1 was an answer, and then here, this is x minus 2, so who's the other guy? 2. So 2 and 1 are both positive. Answer the question? Everybody good with that? Okay. Once again, I just want to